In this video, we are going to solve a problem regarding a circular motion of an object. So the question belongs to a well-known practical situation that is called death well. So in the death well, a stunt rider performing his riding inside a bank track showing this circular motion with a steady circle of radius simple r with the center at the point here. So the speed of a steady circular path is labeled as v. So the principle behind this kind of motion is what the Newton's second law of motion. So the Newton's second law of motion indicates that if something is accelerating, there must be a force supporting this acceleration. So the relation between acceleration and the force is given by this mathematical equation. This equation is not only related mathematically but also directionally as well. The acceleration direction and the force direction are equal. So if this person moving in this circle, the person is accelerating towards the center. This acceleration is called centripetal acceleration. The force supporting this centripetal acceleration is called centripetal force. The centripetal acceleration of this situation can be written in terms of the speed and the radius as v square by r. The force supporting this acceleration has to be directed in this way towards the center horizontally. This force component is actually given by the horizontal component of the normal reaction in like this. This is what we call the normal reaction acting on the person. The other force acting on the person is called weight, that is directing downwards like this. As the question says that the friction is ignorable, we can think of no any force acting either in this direction or in the opposite direction like that. If there was a friction, now there must be a force acting either in this way or that way. Therefore, this frictional force will create a force inclined to the horizontal. Now this ignorance of the friction will make that analysis sort of simple. Now go for applying the force towards the center in this particular situation. Now the mass is written m here, and the force, to get that force numerically, we need to have a angle here. This angle is called theta. So from the geometry you can see this angle and that angle are same. This comes from the geometry. So if you are familiar with inclined plane motions, you can see that this angle and that angle are same. Now we can find the horizontal component numerically as the sine component of the force N, that is n sine theta. This is taken as equation number 1. As the person going in a horizontal circle, person is in equilibrium in the vertical direction. Therefore, the force acting upwards, that is in cos theta, is equal to the force acting downwards, that is mg. This is what we call the equation number 2. So the best way of simplifying this sort of two equations is to take the ratio of 1 by 2, is to take the ratio of 1 and 2, that is what the n sine theta upside, then cos theta downside equals mv square by r here by mg there. This will simplify the mm and nn will drop out, and the sine theta by cos theta becoming 2 tan theta, and here you have v square and gr is written together down like this. Now you can go for the velocity square as gr tan theta. Now the tan theta is needed to find the velocity here. The velocity is written the root gr tan theta. The important thing in this case is that we can find the tan theta from the dimensions given. Now you can see this side is 5 root 3, that is given straight away, and this side can be found from the data given. Then you can find the tan theta. The tan theta is found as the height, that is 5 root 3, by the side. This side, what is the side? This total side. This side is 10 and this is 5. Then this side has to be 5. Therefore, the tan theta would be root 3. Root 3 is approximated to 1.7, that is tan theta. So this would be the 10, that is for the g, tan theta is taken as 1.7 times r, and root of this is what the velocity. So you can take this as 17, then you get 17 root taken out times the r root here, and this is for the velocity here. Root 17 is a constant. This shows that the v goes with the root of the radius. What does that equation show? This shows that the velocity increases. What happens to the r? As the person speeds up, becoming this velocity increased, the radius has to be increased. What does it mean? It means that the person has to go up. As the person going up the incline, the r is going to be increased. The person will take a different circle with a radius greater than that. Therefore, the place in the track will be automatically adjusted according to the speed of the person. That is what this final result shows. This shows that at the maximum limit V max, the r has to be the maximum possible radius, is still making the turns safe. The maximum radius is what, the 10 meter. By putting this 10 meter here, you can find the maximum velocity. Then you can get this as equals root 17 times 10. You get this answer as root 170 meter per second. At the minimum, at the v equals v minimum, you can find r is the r minimum, which is equal to 5 meter in this situation. You can put that 5 in the place of r, finding the v minimum, that is the root 17 times 5. This would be sort of 170 by 160, 85. 80, this is actually 85, root 85 meter per seconds. Actually, these are the two limits of the velocity. Therefore, the range of velocity still making the turns safely is what it has to be lower than or equal to value, or it has to be greater than or equal to a certain value. The minimum is 85 root here, and the maximum is 170 root there. This is what the range in speed in order to make the turns safe. Thank you very much.